Just to remind you, we were working about in this problem, and we want to find the variation in pressure between points 3 and 4. Okay, and I will just here, if in case you didn't have it the chance to look at the video, all you have to do here is to apply the formula that is normal to a streamline. Okay, because you have, if you take the control volume of the fluid, you can consider two directions: the streamwise direction and the normal direction. Okay, when you apply in the previous problem, we have seen the equation in streamwise direction, and if you integrate this relation, you get Bernoulli that we are using. Okay, now if you are moving perpendicular to a streamline, you will have a different relation. And in order to find what is the relation to use, you will apply sum of forces along the normal direction. Okay? If you do this, you will end up with the following result, because it's simple. You should project all your forces on N. What are your forces? You have pressure forces and you have the weight. And all of these details are explained in the slides. Okay? So when you project, you will end up with the following relation that I introduced for you last time. You will end up with minus gamma cosine theta minus del P by del N equals to rho AN or rho V square over O. Now, if you go back to the figure, what is cosine theta? You go back to the figure here. Cosine theta can be replaced by del Z over del N. This is why if you replace cosine theta by del Z over del N, you will end up with the following relation. And this is the relation we will use together now in this problem. Okay, so for a streamline, that when we move perpendicular to the streamline, we can apply the following relation: minus gamma dz by dn minus del p by del n equals to rho v square over O. Now going back to our case, okay, I'll go back to my figure. Okay, this is my figure. Z-axis is upward, Z-axis is up, while un is down. Okay, so what will be dz by dn? What is dz by dn? It should be equal to what? If you have opposite, look, what is dz? Dz is a small element along positive z. Okay, so it's along k. So I consider this is dz, this is dz, okay, and this is dn. So they have opposite direction. This is why when you do dz by dn, it's equal to minus 1. It's equal to minus 1 because un vector is equal to minus k vector. Okay, this is why dz over dn is minus 1, since the two axes are opposing each other. If you want to see it from another perspective, we have seen that dz by dn is equal to cosine theta, and theta represents the angle between k and un. The angle between k and un is 180. So this is equal to cosine of 180, which is equal to minus 1. Okay, so you can replace in your equation, you can replace dz by dn for this problem when you move between points 3 and 4. Okay, dz by dn can be replaced by minus 1. So if I go back, yeah. Okay. Now, if you go back to the formula, we will apply it between points 3 and 4 because we want to compare pressures in points 3 and 4. So I will go back to my formula and I will apply. Okay. So my formula, as we said, you have minus gamma dz by dn minus del p by del n equals to rho v square over O. Now I will write that since dz by dn is minus 1, what if I replace it by minus 1, I will get plus gamma plus gamma minus del P by del N equals to rho V square, okay, rho V square over R. Now, if I replace, I am interested, you know Z3 and Z4. So you know the coordinates of points 3 and 4 in function of Z. This is why I will replace N by Z, okay? So since dz is equal to minus dN, if I replace what, I will get the following. I will get that gamma, so gamma plus dp by dz plus dp over dz is equal to rho v square over r. Okay?
Doctor, why is equal minus the n?
Yeah, I will go back to the figure. Okay? I just explained this, but I will explain it again. Yeah, just let me finish this stuff. Okay? So now dp by dz, I deduce that dp over dz is equal to gamma to minus gamma plus rho v square over r. Okay? Once I obtain this relation, I can integrate to find the variation of pressure. Okay? So if I want to find the variation of pressure between points 3 and point 4, I will take dz to the other side and I will integrate. So I will integrate, if you want, from the first side, I will it's integral of dp between which points? Between 3 and 4. And from the other side, this is equal to integral of the following function, which is minus gamma plus rho v square over r times dz. Okay? Now, integral dp between 3 and 4 will give me pressure at point 4 minus pressure at point 3 equals to gamma is a constant. Okay, this is why I can take it outside of the integration. So the first part, if I integrate the first part, it is minus gamma times z4 minus z3. Okay, so also because I will integrate here also between points 3 and 4. Okay, so between z3 and z4, and here between p3 and p4. So I get minus gamma times z4 minus z3. Okay, and for the second term, it's plus, it's a function, I don't know it. Okay, so plus integral rho v square over r. I will keep it as an integral because I don't know how is the radius of curvature, how the radius of curvature is varying, but I will tell you what is important for me here. So here, what I know is this is a positive function. You have rho positive, v square positive, and of course the radius of curvature positive. So what can you say? And I am integrating between z3 and, so just some people are still joining. Okay. So I am integrating between z3 and z4. Okay. Since this component is positive, rho v square over r, you know that the integral of a positive function for increasing z is positive, because if I integrate a positive number, a positive function, when I go in positive z direction, I will obtain a positive number. So what I know here is that this number here is, this number is positive, which is the integral of rho v square, while this number is negative because z4 is larger than z3 and I have minus. So I cannot know if p4 is larger than p3 or p3 is larger than p4. I should have the function to calculate to conclude. I will go back to my figure to understand physically why this is happening. First,
دكتور بس ما فهمت ليش حطينا Z3 minus Z4 ما حطينا انتي دي
yeah.
Z.
Okay. ما هي integral بس أنا هون ما عم بقدر أحط integration. Okay, look here. If you integrate gamma from Z3 to Z4, what do you get? Gamma is a constant. You get gamma times Z4 minus Z3. Okay? Now here, if you integrate a function between 3 and 4, يعني الborn of integrations are Z3 and Z4. I will show it for you here لأنه أنا ما بقدر أكتبها here. Okay? Look.
فهمت. اوكي طب.
Okay.
Thank you.
First, someone asked me about why dz equal minus dn. Maybe you weren't here when we started. Because z is upward, okay? And un is always directed towards the center of curvature. And here your center of curvature is here, is at this level. So un is downward, okay? Since z axis and n axis are opposite, so vector k is equal to minus un. This is why dz will be equal to minus dn. Okay? Now, concerning what we are doing here, we are trying to compare the pressure at point 3 and point 4. In general, if you don't have curvature, okay, if you move from point 3 to point 4, if you don't have a curve, what will happen? The pressure will decrease, as was the case when you go from 1 to 2. But in this problem, the difference between 3 and 4 and 1 and 2 is that for 1 and 2, you move on straight lines. So you don't have the effect of normal acceleration. However, when you move from 3 to 4, you have two effects. You have the hydrostatic effect. Due to the hydrostatic effect, the pressure of 4 will tend to be lower than the pressure at 3. But you have another effect that is the effect of the normal acceleration. Okay? When you have a normal acceleration, more you are close to the center of curvature, lower will be your pressure. So if you want, if I move from 3 to 4, I will have an increase of pressure due to an, but I will have a decrease of pressure due to the hydrostatic effect. This is why I cannot conclude if P4 is higher than P3 or lower than P3, because I have two opposing effects. Okay? Now, in order to understand why if I move towards the center, the pressure decrease, you can go back to the relation here. If you go back to your derivation, when we did the derivation of motion along perpendicular to a streamline, what did we get? We got that minus gamma dz by dn minus del p by del n equal rho v square over r. If you do a small analysis here, okay, let's assume that this effect is the one for the hydrostatic. This is for the hydrostatic effect. But now, if you look for the normal acceleration effect, this is the normal acceleration, okay? If your normal acceleration is increasing, so when an will increase, minus del p by del n will increase. So del p by del n will decrease. So you can say that del p dp by dn is inversely proportional, or if you want, it will go in a direction that is different than the normal acceleration. So when you have, because look, minus del p by del n, if I don't take the hydrostatic effect, assume that I'm moving along a horizontal plane, so no hydrostatic effect. What do I get? I get minus del p by del n equals to rho times my normal acceleration. My normal acceleration is always positive and directed along un. So you deduce that dp by dn is equal to minus rho an, and which is negative because an is always positive. So always, if I want to take the effect of change in curvature, the change in curvature will tend to decrease the pressure as I move along un, because dp by dn is always negative if I just take the effect of normal acceleration, considering that I am moving in a horizontal plane. Now, if I have motion in vertical plane, I will have combined effect. I will have the effect of normal acceleration and the effect of hydrostatic pressure. So in this problem here, when you move from point 3 to 4, what will happen? You move from 3 to 4. If you take the hydrostatic effect, the pressure should decrease, okay? Because when you go from 3 to 4, you are going up towards the free surface, so you have a decrease in pressure. But if you take the effect of normal acceleration, we have seen together that the effect of normal acceleration, when you have a curvature, your pressure will decrease in the direction of un, and it will increase in the direction that is opposite to un. So now when you go from 3 to 4, you are moving in the opposite direction to un. So what will happen? The pressure will tend to increase. It will tend to increase due to change in curvature, but it will tend to decrease due to the hydrostatic effect. So in total, you have two effects, one increasing the pressure, one decreasing it. To know if P4 is larger than P3, you need to do calculation. Okay? So if you look at the solution here, it will be clearer for you. When you write your expression, this is what you obtain. Okay? You have P4 minus P3, but P4 is 0 because it's the free surface, so it's gauge pressure. Okay? When you do P4 minus P3, you will get, as we did, the integral of V square over R and the term of the hydrostatic pressure. So if you simplify after putting P4 equals 0 and taking P3 to the other side, this is what you get. You get that P3 is equal to gamma H4 to 3, which is the depth, minus rho integral from Z3 to Z4 of your function V square over R. So you can see that P3 is increased by the hydrostatic effect, and it is decreased by the normal curvature, by the radius of curvature, because when you have a curve, in order to be able to rotate your streamlines, you need to lose pressure, because you will lose your energy in another form. You are doing a curve, so this curve will require from you energy. This is why when you go towards the center of curvature, your pressure will decrease. So you can see here the opposite effects on P3, because the hydrostatic effect is trying to increase P3, while the normal curvature, because you are going towards the center of rotation, is trying to decrease P3. So since you have two opposing effects, it will depend on which one is higher to determine if P3 is positive or negative. Question on this?
Doctor,
Yes.
this formula هي تبع ال across a streamline.
Yes. And
Oh,
I
okay.
repeated it now. So I put for you here. This is the slide you have in the course material.
دكتور يعني هيدي دغري حنطبقها ولا لا؟
Yes, you can directly apply it, of course. يعني
يعني هيدي بس كيف جبنا الفورمولا؟
Yes. But look, you should understand the formula, because sometimes, for example, what is theta? You need to know what is theta. Theta is the angle between, let's say, UZ and UN. Okay? So in your problem here, you should know that theta is 180 degrees to be able to apply your relation. So of course you can apply it directly, but you should understand what is the meaning of each term. Okay?
يعني دكتور نحن لازم نعرف كيف نعمل derivation للفورمولا من الأساس لنوصلها.
Look, it's important to understand the derivation. Okay? هلا ما حتحفظها لأنه you have open book, but you should understand the concept, because sometimes in some problems, let's say if you take a control volume, you should know how to apply forces. It's important to understand, of course. But here you can directly apply it in problems. Okay?
Okay.
So let us now move to another problem.
دكتور متى بنعرف أي equation نستعمل along a streamline ولا across؟
Okay. You should look to the direction you are moving in. When you move from 1 to 2, you should know what are the streamlines. What is the definition of a streamline? It's the line joining the velocity vectors. So it's a line that is always tangent to the path. So if you join the velocity vectors, you obtain your streamline. So here, how is your flow moving? Like this. So this is the streamline. Okay, it's following, it's always tangent to the velocity vectors. And because you are interested in comparing pressure between 1 and 2 and between 3 and 4, so you are moving in a perpendicular way to the streamline. So you are moving in the normal direction. This is why you apply between 1 and 2 and 3 and 4, you apply the relations for normal direction. While if you want to compare, for example, pressure at this point and this one, then you will use the streamline equation.
Okay, thank you, doctor.
دكتور سؤال بس.
Yes.
أول شيء كتبت أنت إنه بلس جاما
Yeah.
dz over dn minus partial p over partial n.
Yes.
ليه بلس مش minus؟
لأنه here look, here you have minus gamma dz by dn. Okay, what is dz by dn? It's minus 1. So minus minus is plus, because we said that dz is equal in this problem to minus dn. Okay.
عشان نحن نزلنا 1 unit.
What?
Vertical.
Yes, because z is up. No, look, k is upward and un is downward. K is up, okay, and un is down, okay. So if you take dz, it's a small element in z. This is dz and this is dn, okay. They are opposite. This is why dz is minus dn, because when z increase and decrease, okay, they are varying in opposite direction. This is why dz is minus dn, because k axis is opposing un axis. Okay, this is your k, this is your un. If you have opposite axis, so the elementary variation will be opposite. Okay.
Okay, Michelle. Thank you.
Well, let me check the chat. Okay. So let us start a new problem. The manometer in the figure is the manometer fluid in the figure is mercury. Estimate the volume flow in the tube if the flowing fluid is gasoline and if it is nitrogen at 20 degrees and 1 atmosphere. They gave us for gasoline rho is 1.32 slug per feet cube, and for nitrogen they gave us the constant R of the gas, which is 297 joule per kilogram per degree. Now, what do we have here? We have in this figure a manometer, okay, and you have a flow that is passing through this tube, okay. This is what we call a pitot tube. Why? Because at point 2, what will happen is that we will decelerate the fluid until reaching a velocity of 0. So we say that in 1 we measure the static pressure, and in 2 we measure the stagnation pressure, okay. So here we have static pressure at 1 and stagnation pressure at 2, okay. So this device is used to measure the velocity of the flow. We will understand here how we can use it to measure the velocity. So the first step, we have a fluid that is moving along the tube, okay. So we can use Bernoulli to relate pressures at point 1 and point 2, okay. So first, if I apply Bernoulli equation between 1 and 2, what do I have? I have that the pressure at point 1, P1 plus half rho V1 square plus GZ1 plus GZ1 equals to P2 plus half rho V2 square plus GZ2. So if I replace, guys, please just 1 minute, okay? I will come back for you. Okay, so here I have P2, V2, and Z2. Okay, now if I apply this relation here, let us check what are our parameters. So first, for at point 1, the static pressure is P1. Okay, now I don't know what is the value now of P1. But I will express V2 function of delta P, and after I will see how can I get the difference in pressure between 1 and 2. So I will write P1 plus for V1, the velocity in 1, okay, is the velocity that I should calculate. So I should find what is V1. So I will keep this term 0.5 times rho times V1 square. Now, since point 1 and 2 are at the same horizontal level, these two terms will cancel out, okay, because they are equal. I have rho here, I should add here rho g, okay, it's rho g z1, rho g z1 and rho g z2, okay, but because I have the same level, rho g z1 and rho g z2 will simplify. So now I can get a relation between variation in pressure and variation in flow energy, in the kinetic energy. And look, we know that this is a pitot tube. For a pitot tube, at point 2 the velocity is 0. So also this term will cancel out. This is 0 because at 2 I can measure the stagnation pressure, since the concept of the pitot tube is to decelerate the fluid in order to reach a velocity of 0 at this point. So what I did now, I found the expression of V1 function of the variation in pressure. Okay, so P1 plus half rho V1 square equals to P2. So you can express V1 function of delta P. So this is the first step. In the first step, I found the expression of my velocity, function of the variation in pressure between points 1 and 2. Now, how to continue? In order to continue, I should know what is delta P. To find delta P, I should look at my manometer. You know that a manometer can give me the variation in pressure. So to calculate delta P, I should do the analysis of the fluid in the manometer. So let us see what is happening from point 1 to point 2. If I want to draw a small figure, so this is point 1 here, and at the same level I have point 2. First, if I want to move from 1 to 2, first I should go downward in my fluid. Okay, so first I should go down in my fluid this distance, but I will move again the same distance upward in the same fluid. So these two parts will cancel each other. Okay, then this is why I will just erase them. So I can start the analysis from here, from this level here. Okay, because these two will cancel out. So now, when I move from this point to this one, I am moving in mercury. Okay, and I will just move to this level. Why? Because here I can do jump across, because I'm moving in the same fluid, which is mercury. Okay, so I'm going down, then I'm going up the same distance in the same fluid. This is why I can neglect this part. So for this part, no need to know what is the depth here, because they will cancel each other. Then I will go up now not in mercury, I will go up in my fluid. Okay, so now I can write a relation between P1 and P2. So I will write that P1 plus, since I'm going down mercury fluid, okay, so it's plus gamma mercury plus gamma of mercury, gamma m times what is the times h. What is h here? It's 1 inch, okay? But we will see that when we will replace, we should convert to feet, because here you are using English units, okay? And rho is given in slug per feet cube. So the distances should be expressed in feet, okay? Now, this is the crossover. I go to this point. Now I should go up in which fluid? I'm going up in the fluid that is moving in the tube. This is why it's minus, because I'm going upward, minus gamma of the fluid times the same height h equal to P2. So I can deduce from this expression that P2 minus P1, so P2 minus P1 is equal to H times gamma mercury, gamma of mercury minus gamma of my fluid F. Okay? So
Doctor, just to
yes,
make sure that
yes.
the figure isn't really clear. At which level begins the mercury?
Okay, here. Let me show. Okay, this is your mercury fluid. It's starting from here, okay, and it's ending here. So I will do this. This is mercury, okay? So in this zone, you have mercury. And in the remaining zone, you have your fluid. So everywhere else, you have the fluid, okay? So here you have F, here you have fluid, here you have your fluid, here you have your fluid, okay? You only have mercury in this part here. So this part in red, in this part, you have mercury. Okay, this is why first when I moved from this point to this one and I will go up in the same fluid, I can neglect it because I go up and down in the same fluid. Okay, and in the mercury here at this level, you are going down and up also in the same fluid, so also you can neglect this part because it will cancel, they will cancel out. So only you have two parts where you cannot do crossover, because here you have mercury and here you have your fluid. Okay, this is why. So now I got the expression of delta P. Delta P is gamma, and gamma can be replaced by rho times G. Okay, so if I replace gamma by rho times G for each fluid, so I get that delta P is rho of mercury minus rho of my fluid times G times H. Okay, so now all I have to do is to get delta P and then replace back into the velocity. This is how in this problem you can see how pitot tubes can be used to calculate the velocity of a flow, because for a pitot tube I know that the velocity at 2 is 0. So from Bernoulli I can find V1 function of delta P, and from manometer relations I can get delta P. So if I read H, from H I find delta P, and from delta P I find V1. So here
دكتور
yes.
انت كنت كاتبه فورمولا، فيك ترجع تعيدي بس بليز دغري هيك من بعد الفورمولا لان هالبارت ما فهمتها بليز.
Okay, I write the formula again.
انه من بعد الفورمولا من هون P1 plus half rho V1 squared وتحت دلتا P.
Okay, so here we got this formula first from Bernoulli. Did you understand how we got the formula from Bernoulli equation between 1 and 2?
Yes.
Okay, after doing this, we need to find what is delta P. What is P2 minus P1? To know what is P2 minus P1, we should do the analysis as we were doing in previous chapters. You move from point 1 to point 2, okay? In order to move from 1 to 2, first you should go down in the fluid F, okay? But since you will go up here the same distance in the fluid F, no need to consider this part because they will cancel each other. You go down, then up in the same fluid. Now, once you reach this level here, okay, you don't have the same fluid in this zone and in this one. In this zone, you have mercury. In this zone, you have another fluid. This is why you cannot neglect this part. So you say, when I move from this point to this one, what is happening? The pressure is increasing. So we will write that P1 plus, you are moving in which fluid? In mercury. So plus gamma of mercury times distance h equals to, now here you can do the jump here, because you are going down and up in the same fluid. Okay, so since I'm going down and up in the same fluid, I can directly jump to this point. Once you jump to this point, what you will do, you will go up now to reach this level. You will go up in which fluid? In F. So you have minus, so here just, okay, so since you are going up, you should do minus gamma of what? Of the fluid you are going up in, which is F. So minus gamma F times H. And now you will reach 0.2, since this part was already cancelled. Okay, so this is equal to P2. Okay, so from this relation, you can find that the difference between P2 and P1, P2 minus P1, is equal to H times gamma mercury minus gamma fluid. Okay, so you found what is the variation in pressure between points 1 and 2. Did you understand now?
Yes, doctor, thank you.
Okay, so once I have this expression, all I have to do is to have numerical replacement. In part A, they gave me that rho of my fluid is 1.32 slug per feet cube, and they gave me that for mercury rho is 26.34. So all I have to do is to replace back in the formula. Just I should pay attention that H should be replaced in feet, not in inch, okay? Because G is 32.2 feet per second square, and rho is given in feet cube, so H should be in feet, okay? And you know that 1 inch is equal to 1 feet over 12. This is why when you replaced H here, you put 1 over 12. And for G, you know that in English unit, G is 32.2, okay, feet per second square. So you replace just by 32.2. And for rho, already the value is in slug per feet cube. So you directly replace rho by their values, and you get what is delta P. And once you have delta P, you can calculate V1. Okay. Now they want you to calculate the volume flow rate, Q. And you know that Q is equal to V times A. So knowing V, you should multiply by the cross-sectional area. Here, the cross-sectional area is the area of it's a circle of diameter 3. So it's pi d square over 4. So when you multiply the velocity by pi d square over 4, and of course, d is in feet, use feet, you get q in feet cube per second. Okay?